Hello everyone, and welcome to the What is Networking room in TryHackMe. Begin learning the fundamentals of computer networking in this bite-sized and interactive module. This is a premium room, so you're going to have to be subscribed to the TryHackMe website. Either an annual or a monthly subscription will work fine. Follow along with the tasks in this video. With that said, let's get on to task 1. What is networking? Networks are simply things connected. For example, your friendship circle. Networks can be found in all walks of life, such as the transportation, infrastructure, and postal systems. A network can be formed by anywhere from 2 devices to billions. These devices can include your laptop and phone, to security cameras, traffic lights, and even farming. Scrolling down, we have the question, what is the key term for devices that are connected together? It's going to be network. Check, and it's correct. Okay, send over to task 2. What is the internet? The internet is one giant network that consists of many small networks within itself. The internet as we know it was invented by Tim Berners-Lee by the creation of the World Wide Web, www, that is found by the domain. The internet looks like a much larger version of this sort of diagram. Here we have network 1, 2, and 3. These are called private networks, which are these small networks, where networks connecting these small networks are called public networks, or the internet, which is right here in the middle, connecting all these private networks. Answer the question below, who invented the World Wide Web? So it would be Tim Berners-Lee, as mentioned above here. Copy it, paste it, check. Right, it's correct. Heading over to task 3, identifying devices on a network. To communicate and maintain order, devices must be both identifying and identifiable on a network. Devices have 2 means of identification, with one being permeable. These are an IP address and a media access control address, or a MAC address. Starting with an IP address, or Internet Protocol address can be used as a way of identifying a host on a network for a period of time. An IP address is a set of numbers that are divided into 4 octets. This number is calculated through a technique known as IP addressing and subnetting. IP addresses can change from device to device, but cannot be active simultaneously more than once within the same network. Devices can be on both a private and public network. Depending on where they are will determine what type of IP address they have, either a public or private IP address. A public address is used to identify the device on the internet, whereas a private address is used to identify a device amongst other devices. Here we have 2 devices on a private network. The first one is here, and then the second one, CM-Natic PC. These 2 devices will be able to use the private IP addresses to communicate with each other. As you see here, IP address and their type, private, they have different private IP addresses. However, any data sent to the internet from either of these devices will be identified by the same public IP address. If we check again, the public IP addresses for both of these devices is the same. It's exactly the same. Public IP addresses are given by your internet service provider or ISP at a monthly fee. Alright, so far we have only discussed one version of the Internet Protocol addressing scheme known as IPv4, which is a numbering system of 2 to the power of 32 IP addresses, or 4.29 billion IP addresses. This is a problem because it was estimated before that there will be approximately 50 billion devices connected on the internet by the end of 2021. So we needed something new to tackle this issue, which is where the IPv6 comes in. IPv6 is a new iteration of the Internet Protocol addressing scheme to help tackle this issue. It has a few benefits. It supports up to 2 to the power of 128 of IP addresses, it's 340 trillion plus. So that resolves the issues faced with IPv4 and it's more efficient using new methodologies. What are MAC addresses? Devices on a network will all have a physical network interface. This network interface is assigned a unique address at the factory it was built at called a MAC address, or Media Access Control address. The MAC address is a 12-character hexadecimal number split into twos and separated by a colon. The first 6 characters represent the company that made the network interface, and the last 6 is a unique number. As shown here in an example, the first 6 is the vendor who built the network interface, in this instance, Intel, and the other 6 is the unique number, unique address of the network interface. A thing with MAC addresses is that they can be faked or spoofed in a process known as spoofing. This spoofing occurs when a network device pretends to identify as another using its MAC address. When this occurs, it can often break poorly implemented security designs. Heading over to a practical lab here, the interactive labs simulate a hotel Wi-Fi network where you have to pay for the service. Alright, so if you go up here, it'll show you a view site button at the top of task 3. Clicking it will make half the screen to this interactive lab, the other half to the TryHackMe website. Over down, it says you'll note that the router is not allowing Bob's packets through to the TryHackMe website and is placing them in the bin. So if we try to request site from Bob's computer, the blue one is heading into the bin, that's correct. But Alice's packets green are going through fine because she has paid for Wi-Fi. And you can see here, Alice's computer is connecting to the Wi-Fi and into the TryHackMe website just fine. Try changing Bob's MAC address to the same as Alice's to see what happens. Alright, so copying the MAC address of Alice's computer, here Control C, and pasting it into the MAC address of Bob's computer. If we then request site, it will be allowed to go through. And then you get the flag THM e.on TryHackMe. We can copy this, Control C. Then yeah, there's what is the flag? Yeah, there we go. Check. Correct. Then answering the other questions, what does the term IP stand for? Internet Protocol. Type that in. Checking. Alright. What is each section of an IP address called? It's going to be an octet. Okay, guys. How many sections in digits does an IPv4 address have? It has 4 sections. As shown here, section 1, 2, 3, and 4. This is an IPv4 address. As shown here as well, IPv4 and IPv6. What does the term MAC stand for? MAC stands for Media Access Control. You can take this and copy it. Media Access Control, check. It's correct. Alright, heading over to task 4, ping ICMP. Ping is one of the most fundamental network tools available to us. Ping uses ICMP, Internet Control Message Protocol, packets to determine the performance of a connection between devices. For example, if the connection exists or is reliable. The time taken for ICMP packets traveling between devices is measured by ping. This measuring is done using ICMP's echo packet and then ICMP's echo reply from the target device. Pings can be performed against devices on a network. The syntax to do a simple ping is shown here. Typing in ping and then the IP address or typing in the website URL. Let's see this in action in the screenshot below. Here they're pinging an IP address right here by typing ping and then typing in the IP address. And you can see here how many pings are being sent and the time it takes. Here we are pinging a device that has the private address of 192.168.1.254. Yes, ping informs us that we have sent 6 ICMP packets. Yes, it says right here 6 packets transmitted, all of which were received. Yeah, 6 received, correct. All of which were received with an average time of 4.16 milliseconds. This is shown right here. The RTT minimum, average, max, and deviation, and node average right here 4.16. So now you're going to do the same thing to ping the address of 8888 on the deployable website in this task. Pinging the correct address will reveal a flag to answer the following question below. All right. So we have question below. What protocol does ping use? ICMP. What is the syntax? Ping the 10. Just ping and then turn. Correct. All right. What flag do you get when you ping this IP address? We're gonna deploy it. New site here. Right, it already has the syntax written to us. Just put in the IP address 8.8.8.8, then send ping request. Here it's only gonna send 4 of these, and because we have placed this right here, -C, which is account of 4, within the IP address. So it says right here 4 packets transmitted, 4 received, and then the flag THM ping the server. Ping this, we'll see, and then placing it here, and then check, and it's correct. And then over to task 5, continue your learning, then to line, and this is going to be the end. The next room will be the entry command room. You can just, there's no answer needed here, you can just press check. And that's it. Great work. The rule has been completed. Thank you for watching, and I'll see you in the next one.